And just for information, this session is recording in recording mode. So hope that is okay with everyone.
Yeah. So we'll start with a brief introduction about ourselves. So hello everyone, this is Sachin. Uh, I have primary experience in front end and currently I'm working in TypeScript and React. Yeah, hope you have some learning from this session. Will be four of us, including myself. So I'll request Prabhu to introduce.
Yeah, hi guys, my name is Prabhu. So I have primary experience in front-end development in JavaScript and React, but I've also worked as a back-end developer in the JavaScript ecosystem. So yeah, I'm excited for this session. Let's make this session very interactive. Don't be afraid to ask any questions or put some questions in the chat. So yeah, Shashank.
Yeah, hi guys, good morning. So this is Shashank, and I also majorly worked on the front end side in JavaScript, and also currently I'm working in the TypeScript ecosystem. I hope to share some knowledge that I gained working on TypeScript through this session. Yeah, thanks.
Hello everyone, my name is Samdra Sadamin and I am a front-end development. My expertise is in React. So I hope you guys have a learning today, good learning today. So we'll start. I will just share my screen. So is it visible? Can anyone confirm?
Yeah, it is visible for me.
Yes. Yeah. So welcome everyone to the TypeScript session. Uh, we will in this session we will see what is TypeScript, why we should use it. We will see some basic concepts like static typing and primitive types, and we will also dive deep into the advanced concepts. Okay. So first of all, what is TypeScript? So it is a superset of JavaScript, and which adds type safety to the JavaScript code. So all of us knows that TypeScript does not have, JavaScript does not have this static typing in it. So TypeScript fulfills this need in JavaScript, and we can add the static types in JavaScript. And it is free open source programming language. It is developed and maintained by Microsoft, and it does not change the runtime behavior of JavaScript. As we will see in this session, that all the TypeScript code is converted to JavaScript, and what TypeScript provides is just compile time. It provides us a better error resolving solution in compile time. So in a survey, more than 15,000 people feel that we need static typing in JavaScript also. So this is just a reference to that. And so as I told you, suppose there is a function in JavaScript which takes two numbers and returns the multiplication or division. So if we pass string in that, JavaScript will not give us the error in compile time. So in TypeScript, that error will be shown in the compile time only. So that is, so it has potential to move the errors from runtime to compile time. That includes potentially absent value or incomplete refactoring. It serves as a foundation of a great code authoring experience. So uh, two things to note here, that on TypeScript is only activated during the development. So in the runtime, it is the TypeScript code is before the runtime. TypeScript code is converted to JavaScript, as you will see, and it doesn't provide any performance optimization like other languages that uh, static typing can be used as optimization. So we will see how to install TypeScript in our system, and So before that, the Node.js should be installed in our system, and command to install TypeScript is npm install TypeScript, and to compile the TypeScript file, it is npx tsc and file name. So this command npx tsc file name, it catches any type error in the TypeScript file and creates a JavaScript file with the same name. So uh, let's go to the VS Code and try this out. Okay. So in this VS Code terminal, I will try to install TypeScript here with this command npm install TypeScript. Okay. As I've already installed TypeScript in our system, so it is just updated that package and we are good to go. So in the code, we can see a JavaScript. I mean, it is a TypeScript file, but the code is JavaScript yet. So we haven't converted to TypeScript. So what it does is it multiplies two numbers, A and B, and returns the multiplication of the numbers. Okay. And in JavaScript, if we give a string here, suppose, so this Java, I mean, we will not get error at the compile time in JavaScript, but it will throw us some unintended bugs while runtime. So in TypeScript, how should we tell the TypeScript to that it is a these two numbers are only these two variables are only numbers, not anything else. So we just add a colon and type number here. So it will tell us that this is a number, and we'll do the same to B also. Okay, and we'll save the file, and let's try to add a string here. So here you can see all we get a red underline here, and we see that the argument of type string is not assignable to the parameter of type number. As we can see, we can get an error here. So this can be solved here, and even if we try to compile this file npx tsc and example.ts, so here also, okay, yeah, here also we'll get an error that says that it is a argument of type string is not assignable to type number. Okay, so we will just uh, remove the string and add the number, and again we will try to compile it, and we can see the JavaScript file is created here, and when we open it, that it is the same it is a very similar code to the type code that we have added in TypeScript file, but the all the typecasting is removed from here. So we will dive deeper, much deeper into this typing system. This is just a small introduction about how the typing is done in JavaScript, and we can also add a return typing here with this after the brackets of the parameters, and we can add column here, and we can say also say number here, but don't worry, we will go much deeper into this in few minutes. So that is all from my side. Next speaker would be Sashank, and before that, if you guys have any question, you can ask, otherwise we can move on. Are you good?
Yes.
Yeah, Shashank, you can go ahead.
Yeah, thank you, Somi. So let me share my screen. Yeah, so I think we have covered what and why JavaScript, TypeScript, and also installations. So let me quickly go through the type systems in general. I mean, not in TypeScript, but the type systems themselves. So if we want to categorize the type systems, there are many ways, but let me talk about the two ways in which we can categorize the type systems. One is the static and dynamic, and another is the nominal and structural type systems. So yeah, so when it comes to static type systems, it means that the types that we are giving, that we want to give to our variables and uh, uh, variables in our language, we simply we need to give them explicitly. I mean, we need to type the types. But in case of dynamic type systems, those we don't have to type the types. The language compiler itself infers the type whenever we are giving initializing the variables. So that is one way to categorize the type systems. And the other way is like nominal and structural. So the nominal type system is all about the names. So I mean, names are, I mean, the name of the type that we are data type that we are defining is important in case of nominal type systems. In case of structural type systems, the name doesn't matter as long as the structure is same, the shape of the type is same, the language is happy with that. So where the TypeScript stands in this ecosystem. So TypeScript is basically a static type system, and it is also a structural type system. So let me quickly show you how it looks like. I mean, comparing the static and dynamic, and also the nominal and the other type of type system. So yeah, so here basically I have an example. So I'm hoping this is basic TypeScript JavaScript code. So we will go much deeper into classes afterwards, but to prove that it is a structural type system, I have this example here. So I have a class which has some simple property name. So basically class is a kind of data type which has one property called name, and which is a string. So we will go through this annotation in a little bit. So we have this person, one data type, like it is a class. And also let's say we have another data type called employee, and it extends it extends the person. I mean, it will have these both properties, name and price, when we initialize a object using this class. So this is one part, and I have another class which has product, which explicitly has these two properties in them. So basically employee also has name and price because of this extent, and product by it explicitly has these two properties. So these two are even though these are different classes, they have the same properties in them. So I have an example function. So a foo function which takes an argument of product. So it is accepting a product type, and it returns void, let's say for the time being. So now when I call this function by initializing an employee object, TypeScript doesn't show me any errors. So like VS Code has a very good integration of the TypeScript ecosystem. So we will be getting errors if we do any mistakes here. So yeah, now I mean, if you look at it, there is no errors here. This is because TypeScript is a statically typed and also a structural type system. Only the structure matters. So I have an example of Java here. If anyone is familiar with the Java, they can go through it. We will share this code with you. So here basically, in case of languages like Java and C++, the type, I mean, the name of the type is very important. So if I have a same function here, so which accepts a product, but if I pass a product object, there is no error. But if I pass an employee object, it will show an error when you compile. So that's about the type systems. I hope you guys understood the type systems in general and where the TypeScript falls into these categories. So moving ahead, yeah, we have type annotation. So how are we defining types in the TypeScript? So TypeScript uses this annotation syntax where we declare the variable with our keyword like let-var const and give its identifier name, and then we annotate it with colon and then define the data type here, and then we can initialize with whatever we want to initialize. So this is basically is type annotations, and this is how we add types to JavaScript using TypeScript. So what are the data types that are available? So like in JavaScript, we have primitives and objects, arrays, and all. But TypeScript also has some special data types like unknown, any, void, and never, which we will go through it. And basic, the string, number, and Boolean are similar to the JavaScript language, and they themselves like describe what is string, number, and Boolean. String is basically a string, and number is anything number, and Boolean is true and false. So apart from these things, we have literal types where this string, I mean, these primitive types basically means a string can be any string, a number can be any number, but literal types means it is a particular string, or it is a particular number, so, or it is a particular type of object. Those are the kind of literal types that we have in TypeScript. We will look at these examples in few minutes. And also we have enums, which when we have a set of possible named constants, I mean, if our variable can take only a few of the defined variable names, then we can use enums also in using TypeScript. These are basically similar to other languages, if you are familiar, like other statically typed languages, with few exceptions, which we will look into. So yeah, going into examples, we have these primitive types here. So now I have these are kind of examples for string. So yeah, so basically there is kind of two ways in which, apart from the annotation that I have showed you, there is other way that TypeScript has some intelligence to guess the types of the properties. So that is called the implicit inference. Here I'm just initializing this variable, say let message equal to hello world. I'm not annotating anything. So if I hover over this message, now I can see that let message equal to colon string. So TypeScript is intelligent enough to infer the types. So now if I assign anything, say I have another variable color, and it is also a kind of string. So if I hover over it, it is a string. So if I try to assign it to a number, so now I can see number is not assignable to string. So this is one way, like type inference is one thing that TypeScript does for us. And other way is like using explicit type annotations, where we do this colon and string. And there is some caveat around this. Yeah, this is the inference section. So yeah, so the thing is, if the inference basically happens when you declare the variable itself. So here I'm not initializing it with string anything, like I'm not doing string number or anything. I'm just declaring let message. So if I hover over it, then the TypeScript infers that it is as any, like it can take any value. There is no restrictions of here. So by doing this, we are basically not getting any help of TypeScript. So we should not do this. Like we should not rely on this inference thing if we are not initializing the variable while declaring. So here I'm trying to do a string and the number, then there is no error here. So we should try to avoid this and take care of that one. So yeah, we can also have this even with object, like object wrappers, the inference works. Let's see, like, yeah, we have this color string. So this is another way of defining strings. If you are doing this way, even then TypeScript helps us. So, and also we can have multi-line strings also. Even then, here we are not doing, I mean, we can rely on the inference because we are initializing the string here. So that's about strings and the things that we need to take care of. And when it comes to numbers, I mean, numbers, there is kind of very broad way of defining numbers. Like since this is a statically typed language and there is only one data type like number, so here it can accept, like we will see different types of numbers. So here I'm not, yeah, I think this is kind of similar example of the type inference that I'm doing. So here number is any and number is any, and we should not do this basically. And yeah, here I'm explicitly defining number and then assigning, and if I assign anything other than the number data type, then it will show error, string not assignable to number. And apart from that, we have nan and infinity and these things. So these are also basically number data type in JavaScript and TypeScript. So I have, if we try to see what TypeScript infers, then yeah, nan is a kind of number. And similarly with infinity and negative infinity. I have examples for these also if we want to see. So these are basically a type of numbers. So even with the decimal, hexadecimal, all of these are kind of numbers. I have examples for this here. And yeah, so that is number. And we have one more thing called big int, which is data type in JavaScript also. So if the number is greater than this this much 2 power 53 minus 1, then we have a big int data type. So if we try to see what it infers, it is a big int data type. So that's about numbers and the literal types that we are talking about. Let us see how it works. So here I'm initializing a value. I think I haven't. Yeah. So here I'm using the let keyword and initializing this variable. So if I use let, it means that I can reassign this variable. So by this, TypeScript knows that it can be any string. So, but if I use const keyword, so basically const, we cannot reassign kind of thing. So if you try to see what bar is, then it is not a string anymore. It is a it is the type of string here that I'm giving. So let's say something else. And if I see, yeah. So bar can be only this one, bar 2. It is not a string, or it cannot be any other string. It is only, it needs to be this string. And the same thing that that I was explaining, we can reassign it, but bar we cannot reassign because it is a constant. It is also this particular data type. And Boolean, it is most simple kind of data type where we have only true and false. This is kind of inference, and this is the explicit one, and that's about number. Now Boolean. And yeah, enums, this is one more example of enum. So enum, basically we can have 2 ways. One is declare this enum, and usually the convention is to have capital letters for this. And we have an enum of weekends, and weekends can have only these types of values. And the way that we define, I mean, the syntax is like we can either initialize this to some value, or we can keep it as it is, and we will see how we can access those values. So in the first way, we can access it with the dot syntax, dot Monday, then it will return 1, or else this brackets one, or the index one that I was talking about. So the weekends and give an index of 1, then it will be whatever is there in the 1, we will get that one. And yeah, that's about it. And other way is like not initializing. Then in this case, it is initialized with 0 index. So either we can do same thing, but we will get this value as 0. And since it is 0 index, then we will get weekends 1, it will be Tuesday. So that's about enums. And yeah, union types. So we have this primitive types, but if we want more complex types, then what we can do is we can combine different types to get a new type. So the syntax is like type 1, pipe, and type 2 and pipe. So we will see in a moment like how this works and what is the final result we will see. So I have an employee ID, and let's say it can have string or number. Let's say, I mean, if we say we are getting a JSON from a database where we are storing it in kind of number string, but sometimes in our application we know that it is a number, but that is how we get from the database. So it can be a string or number. I mean, by converting it into like parse or something, %, or something like that, then it can be number 2 in our application. So I'm creating this variable by annotating it as a string, pipe, and number. So if I hover over it, then we can see that it can be a string or number. And if I assign it a number, then no complaints. And if I assign it a string, then also no complaints. But if I assign it any other thing, then we can see that the error shows up. So this is the union operator is kind of very much helpful in combining types. And there are very important use cases that we would came across with the help of this pipe operator that we will be seeing in the future sessions. So that's about union type. And also there is an intersection type too. So we have this intersection type with hand. We will see the, I mean, the use case of it we will see in future, like when we discuss objects, we will see how that is useful, the intersection operator. For now, the pipe operator is when we want to combine different types. That is the thing. So moving on. Now I want to talk about the type aliases and the interfaces. So we have seen the primitive types. So for primitive types, we can just annotate the types and all. But there is even for primitive types, if we want to reuse the types, say in employee ID has the type of employee ID we want to use at multiple places. Just now we have seen it is number or string, but we want to use it at multiple places. Instead of just annotating it on the declaration step, we can use other ways also. So that's when type aliases and interfaces come into picture. So those are basically the same thing. I mean, similar things, but they have their own limitations and use cases that we will see. So talking a little bit about type aliases, they define more meaningful name for its type and also declare the particulars of a type in a single place, and they can also be kind of imported and exported across modules. So this will help us in reusability and modularity. And interfaces also has a similar thing. They have their interfaces can be extended, but types cannot. So we have that kind of differences. So let's have a look at some examples. So yeah, just now I talked about the reuse of number and string in an employee ID. With the help of type alias, I've just defined type, and I will give this one. And the basic convention is type and interfaces. We will declare them with the capital case, like first letter capital. We will that is the convention that we use for these types. So this is a type alias of an ID, and it is a number or string. And now I can define any number of variables with the help of this type alias. So now it will be of type ID, and type ID is a number or string, and I can assign it to a number or string. So there are no complaints. So that's how types are useful. Okay, and yeah, I mean, most of these types can be used for primitive types also. Interfaces we cannot use for primitive types, that we will see. So that is one kind of difference, and we will see more about defining types for objects in a little bit, and how we, I mean, the inheritance that I just talked about, how we will be achieving inheritance with the help of type aliases. So this is one example where, and here also we have this intersection operator. So I have a type which has basically all the properties of the date object, and also has some property kind of thing, get reason why it is a special date. I have some method on it. I want to have this type to have all the methods of the date and also a method. So then here basically we are inheriting all the properties of this and also having this property with the help of this intersection operator. So that is kind of covers two things: the intersection operator and also the inheritance in the using type alias. So I have an example for that. So I'm creating a new date, and I'm just using this spread operator to give all the properties that a date has, and also give my property. So if I remove this, then I think it will show error. So yeah. If you look into it carefully, then we get to know that this special date we cannot assign because it is missing some property. We can dig deep into it once we understand all the things. So that's how That's how it works. So that's one example of this intersection operator and the type alias. So interfaces we will look in a bit when we are discussing objects. So that's about type aliases and interfaces, objects. Yeah.
Sasank, one question.
Yeah.
So the type aliases you showed, so
Mhm.
there you have used means all capital case, for example ID. So
Mhm.
is this a personal preference or it is a convention?
Yeah, it is a personal preference. We can do anything.
But
So the
I should be
convention basically is to have the first letter capital, as with any class in other languages.
okay. Thanks.
So yeah, now we have the objects. Let's look into the objects. So anything that is not primitive, like any JavaScript object, is an object in TypeScript 2, and it is basically a collection of key value pairs. And they provide, I mean, this is a basic thing that we have, like this provide a way to group several values into a single value, a few ways. Yeah, this is important, like how we are assigning types to objects. Like I mentioned, type aliases and interfaces are one thing, and apart from that, object literal syntax is one more thing. This we will look some examples now. So now I have an example, like this is an object literal syntax, where here this is basically kind of thing, the infer thing that I was talking about. I'm just declaring a variable here and giving some properties. And if I hover over person, then you can see that person can be only this thing. It is not kind of any type or any interface, but only this. So similar to the literal that we talked about when looking into string, this is the same thing in case of objects. So it can be only this object and nothing more. So that is the object literal syntax, and that is one thing. And name types is another thing that we have. So name types we achieve with aliases and interfaces. So I have an example here using an alias. So I have a user contact info which has a name and email, and I have yeah, this is some other example, like I have another object, another type of profile and post IDs, let's say, and this is a array which we look into it, string of array, and we have these properties, and I define an object of these two types, and I need a name, email, and also I have this missing. Let's see. Currently, I think it's complaining that I have some missing fields. So let's say profile URL, some URL, and post IDs. So yeah, now it works. So this is how we define objects. We define types for objects using type aliases. And when it comes to interfaces, we have similar syntax where we have interface and the capital case that we have, and we have name and email, and define the types for that. And we can define similar to this. We can have any other object, like say const. I have some user of type user info, and if I provide these things, I have some, let's see, identifier expected.
I think equals to is missing.
The variable
Equals.
declarations at 45 line.
Yeah, sorry, got it. Now we can see, now we can have a user of type user info. So this is with the help of interfaces, that is how we have. Now how inheritance works with the help of interfaces. So I have some simple example. I have this extend keyword which I can use, like I mentioned before. I have an animal interface one. It has one method which returns a boolean. We will look into functions in more in detail, but this is how we give types for methods using interface, and also has a here I'm inheriting with the animal methods. So I have an interface called mammal which has both these methods, and that is one way. And similar here, a dog is a kind of mammal, and that is one thing. That is how we achieve inheritance. So we cannot do that in case of types. We have that flexibility only in case of interfaces. And yeah, and we have one more thing, implement. So when we talk about classes, we can have this one. So we have basically some contract like this type needs to have this one. So if a class implements this animal like interface, then it has to define this method. We will also look into this afterwards, but yeah, this is how we can make use of interface. There is one more way in which objects can have types. That the use case is like in case of dictionary. Say we have some string, any string, which is here we are defining like it has to be name, it has to be email, but there are some cases where the key can be any string or any symbol. So in such cases, how we define types? So index signatures are helpful in such cases, where here is an example of that. So we have this square brackets, and we define this key name. It can be anything, this variable particular thing, and this has to be the type, like it is string, or it can be a symbol. Like we know in JavaScript, like the indexes are basically kind of strings. Those are codes to strings anyway. So it can be string and a symbol. So this is common for anything, and this is a type that we want to have for our string. So I have an example here, like I have a dictionary here. Say I have numbers for home, work, facts, or anything, but these are strings, but it has to be of this type. So basically I have defined this. So that's how we can make use of index signatures. Now I look into it, phones.new. So I can see that it has these three properties basically defined here. So that is about index signatures, and also the objects, how we add types to objects in general. So moving ahead, yeah, now we have arrays. So arrays has basically two syntaxes. One is this type and square brackets, or we can have array and also have this angular brackets and define the type in there. So here type can be anything. That it can be type alias, it can be union of types, it can be anything that we described before. And there is another interesting data type that we can make out with the help of arrays and TypeScript. That is a tuple. So sometimes like we may have multi-element array, but those are ordered data structures. Say I have a string number pair. So I always know that the first element is a string and second element is a number. So then I can define this, and it basically becomes a tuple. So it has like some few use cases. If you came across that in your application, if you notice them, then maybe you can make a tuple out of it and define the type. And yeah, it can also have some optional parameters, which we will look into. And also, yeah, there are some limitations with tuple that also we will look into in a few minutes. And yeah, let's see some code. Aliases, index signatures. Okay, now coming to arrays. Yeah, so I have an example, simple example. Like I have defined a constant file extensions, JS and TS. If I try to see what it infers, then it is a string array. And it is intelligent enough, like if I have multiple data structures here, a string and a number, and now I try to see, then it is a string or number, like it is automatically inferring this pipe and doing this thing. So that is one way. or I can create an type alias or interface and explicitly do that one. So yeah, in case of primitives, we can rely on the inference, but in case of objects and arrays, we need to be careful because we might have empty arrays. And if we do not do this, then it is kind of, let's see what it does. So it's, I mean, there is no type and error. We will see never also. So yeah, we should not do this like we did for primitives. We should be explicitly defining types always. So I have a user array, and this is of type user, and this is one syntax, and the other syntax is array and user. So that's about arrays and basic use cases. And now if you look into tuple, so I have an example here. So I have, say, now, like I mentioned, if I try to have this and try to see what it infers, it is string or number array, right? So, but I know that my data structure is always like this, and I know that first one will be an array, second one be a string, and third would be a string. So basically, I know this, and also there is some where it is useful, like we can destructure it with the help of ES6 destructuring syntax. So this is one useful way to reduce our code. So we may came across such situation. So in that case, we cannot infer this because it's showing string and number. So if I put anything, then it is fine with it. Like not only this, if I do 1, 2, 3, then also it's okay. But that is not what we want, right? So that's where tuples come into picture. So I define a type alias here and say it's of number, string, and string. It has to be in this order, and it has to be this data type only. And now I can define a variable called core and say it's a core and give number, string, string. And so if I try to see if I give string, then it will show error. If I give to number instead of string, then also errors out. So type string is not assignable to number because it has to be a number and it has to be a string. So that's how the tuples are useful. And the limitation is that it only checks for number of it also checks the number of arguments. Sorry, it's not a limitation, but yeah, it also checks the number of arguments. Like here, when I was doing the number of arguments, there was no error, right? So that is how it can be useful. Now coming to the limitation. So the limitation is that when we do like any modifications to this particular variable, so TypeScript cannot infer that or cannot check that. Like I have a number pair, I have 4, 5, 6, and I'm doing operations such as push or pop, then there are no complaints here. We need to be careful enough that we are not doing any such cases. So that's about the tuple. Yeah, so that's all from my side. Thank you, and I'll let Sachin to take over and share some of the interesting examples going forward. Thanks.
Thank you, Sasank. Let me share my screen. Let me know once it is visual.
Yeah, it is visible, Sachin. I hope everybody else can also see the screen.
Okay. So we can start, right?
Yeah.
Yeah, thanks, Sasank. You explained all the primitives and octal arrays and objects. So for the participants, like if you have any queries, feel free to interrupt me, or else you can also make use of the chat. So people can answer there as well. So with that being said, let's start with functions. So you might be well aware of functions because JavaScript, the heart of the JavaScript lies functions. So TypeScript has some basic typing system. So how functions can be typed, and it will be like the coding can be easy with TypeScript. So TypeScript has this basic function typing. If you look at the syntax here, which is highlighted, so param, string, which returns a void. What this syntax means to TypeScript is a function with one parameter, which is named param here, which is of type string. So param is a parameter, we can say, and the type of the parameter is string, and this function doesn't have a return value. So when we come across void in TypeScript, it is identical to undefined in JavaScript. So JavaScript doesn't have void in it, but if you are familiar with Java or other compiled languages, so there we know void exists. So yeah, void is some extra addition from TypeScript. So if you don't have any return type, then we can simply mark it as void. So the second point, like option parameters can be typed with question mark. So there are scenarios, right, in JavaScript functions where we define optional parameter towards the last of the parameters list. If we have 2 to 3 parameters, out of which the last one should be optional, or it can be optional. The first, if all of them are optional, then it's okay. If any of the parameters are not optional, this should be compulsory, then we should put them at the first, and the optional should be towards the last. So in TypeScript, we can mark that optional parameter with this question mark. And void is not same as undefined here. So as I said, TypeScript introduces this void concept. JavaScript doesn't have it. So undefined means the typing is undefined is itself a type here. Void is also another type. The difference is for a return type of a function, if you don't return explicitly, or you return and put a semicolon after it and without returning any particular value or something, then TypeScript will infer that the function has a void type. Undefined is like the value is not assigned to a particular variable. So in that case, it will take undefined as the type. Coming to callback of a function, we use callback, right? Many cases. So in callback also, we should be very careful when we mark some of the properties of the callback optional, because when we put question mark for the particular parameter, then it can be undefined, right? If the during the uses of the particular function which takes a callback, if the at the use place the user doesn't pass the optional parameter, then it will take undefined. So we should be careful enough when we define a callback. We should be particular about using this optional parameter inside a callback argument list. A function can be called in different ways, can be typed by writing overload signatures. So this I'll explain in detail with examples, because overload signatures are somewhat new to when we compare with JavaScript and TypeScript. JavaScript doesn't have it, and with TypeScript we can define like multiple flavors of a function with same name and same number of arguments, but the types of the arguments can be different. So that is what overload signature stands for. If this is not inferred from code flow analysis, it can be typed. So in JavaScript, you cannot, this cannot be changed in a particular context. But in TypeScript, you can always type the this keyword. So the next key point is unknown is type safer counterpart of any. So as Sasank also touched upon it, any we should always avoid in typing. We should always strive for making use of unknown in possible cases, because with any what happens, it any is like anything can be added to the particular variable or argument or return type for that matter. So if we don't know at the time of the defining of a function that we don't know what return type will it have, or what argument it can take. So in that case, we should prefer unknown over any. We'll also see examples in for this. The type annotation on REST parameter is implicitly any, array of any. So as you might have seen, right, when Sasank was explaining, if we miss typing for any particular variable when we are defining, so for example, let who, and we don't initialize it also. So in that case, TypeScript will infer that variable two of any type. But when we are talking about REST parameters inside maybe a function argument, so in that case, TypeScript will infer that it will be it is a type of array of any, not simply any. So with these key points covered, let's go to some of the examples. I hope my VS Code is readable. Okay, so I'll start with this simple example, type greet. So greet is a function, and this is how it is. Sorry, greet is a type alias, you can say, and this is the type definition of the type alias greet. So what it says is it has a parameter named guest, and the parameter has type which is string. And also, if you notice, the question mark is there. So what it means is this guest parameter can be string or undefined. If I have to say it otherwise, so it can be also, it will be also similar typing, string or undefined, or you can say question mark here. So guest can be string or undefined. If I hover over this also, you will get the same thing. And the return type is unknown. So I don't know like what greet typing will take as return type. So I'm marking it as unknown. So when we use this type alias, we should go with the chart function. And if you see, I'm using this type alias greet for this greet parameter for chart function. So again, so to the greet parameter of this chart function, I'm assigning this type alias greet here. So this greet parameter should now adhere to this particular typing. But there is also one question mark here, which means greet can also be undefined. So if I hover over this greet parameter, so greet parameter should be of type greet, which is a type alias which is defined here, custom type alias, or it can be undefined. So now if we move into the function body of the chart, so greet can be called, right, because it is a function. But the catch is greet can also be undefined here. So the TypeScript is angry now, cannot invoke an object which is possibly undefined. So we can make use of the optional chaining of feature of the JavaScript. So this is pretty JavaScript concept, but to briefly explain, check if greet is not undefined. If it is not undefined, then call this function, greet function. If it is undefined, then we can move ahead in the function body. So yeah, so greet, we can like this way we define the function typing, and we use the function parameter. The here function is a parameters, and we use it inside the function body. I hope this is clear. Any questions around this? Okay, I'll take that as no. Next, we'll move on to overload signatures. So what overload is briefly, overload signatures are special feature of TypeScript, and function, if you see the function fn, with same fn function, I can define multiple flavors of that function, if I can say that. So if you see these two definitions, so fn is a function where the first one is taking x as parameter, which is of type Boolean. and the return type is void. And in the second definition, again, the function name remains the same, the argument name remains the same, but what changes is the type. So now it is taking string as type and void is the return type. So this is like not possible in case of JavaScript, but this feature is coming from Java and other compiled languages. So overload signatures are those which have same function name, same number of arguments, and but what changes is the type of the arguments, and the return type of the argument also can change. So here I am keeping only the change in the type of the argument, and let's see the implementation signature for these two overloads. So these are like basically types of the function, like what different type it can have, the fn function can have. And when I define it, that we call implementation signature. These are two taxonomy you can remember. So implementation signature, when we implement the fn function, so now we have to deal with both boolean and string, right? So the typing what we will introduce here is the union of both the types. If we have multiple, then we should have included that also, or else means any superset which will include the individual cases, for example boolean or string here, so that will do. If I remove any typing here which will exclude one of the overload signature, then we'll get error around that. This overload signature is not compatible with its implementation signature.
Sachin, I think Leela Ram raised hand. Leela Ram, you have any question that you want to ask?
Yeah.
Yes.
So basically, whenever we have this implementation signature, right?
Yes.
So how do we have to check whether the X can be a Boolean or a string? So basically, if you look at it, 28, 29, those two would be completely different functions that we are using it. But
Yes.
In the TypeScript, how do we implement that? Like we check the type and then we block out that one, or is there any other better solution for that in general?
Let me know if I understand your question correctly. So your question is around, like here we define it as Boolean or string, that is fine. But inside a function body, how we can make sure that what our X type is it?
Yes, yes.
Okay. Yeah, so I deliberately left that function body. So I'll explain it now. So now when we see the implementation signature standalone, so the type is, as you can see, string or Boolean, we have typed it here. But how inside function body will make sure that what type is it? So for that, we can make use of type of operator. See, it's already giving me suggestion. So type of X, I can say, and type of is already part of JavaScript. So I'm assuming you are familiar with this. And yeah, so when I check the type of X, and I know that it can be either Boolean or string. And firstly, I'll take string as the case. And now if I go inside the function body, sorry, the if clause, and I console log it. So now if you see, the type is string. From here string to Boolean, we can reduce the case to string. So now if I have to do any string specific operation, for example, to lowercase I am doing. So now I can do that because string has this method. Outside it, I can't do that because here X can be Boolean, right? It can be string or Boolean. So TypeScript will complain about it. So inside I can do any string specific operations. Similarly, if I go into else block, if it is not of type string, then it should be of type Boolean. So I can say I can do any Boolean specific operation, or I can simply log it out and check that it is of type Boolean. Does that answer your question?
Yeah, got it.
Okay. Any other question?
In general, the reason why I'm asking is like whenever we are writing some sort of production ready code, right? So generally, a check on top level for a data type is generally been avoided, and moreover, they in the peer comments or anything, they would try to ask us to go with some sort of a different approach rather than the approach right now we are using it, right? That is the reason I asked like how could we go about it, but I understood what you said.
Okay. So actually, to add to the point, like we will be using this particular type. Means when we are, this is, you can say that some library we are using, and for that library the code is written in JavaScript, and but in our production code we are using TypeScript. So we'll have to prepare a index.d.ts file if you are aware of that. So in that case, we'll have to define the overloads and implementation signature from our part. If the library itself is not in TypeScript, so we'll have to make typing for the library, and then we'll have to write this kind of cases. So if the function is of this type, means the user passes Boolean argument to this fn function, then it will be of this type. And if the user passes string argument to this function, then it will be of this type. The implementation signature is like it should be the superset. Otherwise, it's very difficult to means inside the function body, it's difficult to means know what the type of the argument is. So ideally, we do this way, but there can be other approaches also. Okay.
Yeah, got it. Thanks.
Okay. Yeah, so I think I can move ahead. Yeah, the next I have unknown versus any. So we also Sasank has also explained about this, but in function context, there is a simple example I have prepared. So look at this example with function with any example, where the argument is of type any, and a is of type any. So I can do any operation inside it, and TypeScript will not know what I am doing. So if I hover over B, so you see B is of type any. But looking at this example, one can easily say that A is an object and B is a method inside. B is a method inside the A object, and we can call that method. But so in that assumption, B should be of some type, right? B should be of type function or something. But TypeScript will allow us to do anything with it. A can be anything. So it will never complain about A, because we are defeating the purpose of TypeScript here with when we are using any. So to avoid that, we should always use unknown, as I said, and the similar checking we can do before calling any function, sorry, or any method inside an object. So if we assume that A is an object, so we should check this, and now it should be a object, or null, it is inferring that it can be null. So that check also we can implement. So the point here I'm trying to make is any should be avoided in all possible cases. If I don't know the return type of any function, so if we go to this function body json.parse of and we pass some string into it, I don't know what the result will be, whether it will be an object or it can be an array. So in that case also, we'll prefer unknown over any. Any confusion here? Okay. So last, there is a small concept of never. So this is a small like basic function example where we pass message as an argument and we throw error simply without doing anything. So here, if you hover over the function definition, So fail is of this type, where the message parameter is of type string, and the return type is void. But the appropriate typing would be to do never here. Why? Because we are not returning anything. So, and we are not returning anything, also we are throwing an error. So returning from this function, we can't expect that we'll be getting something, not even undefined. So it should be of type never here. So this is a simple use case for never. Generally, we don't use never that much, but yeah, this is a simple use case to explain never. So with that, I am done with functions. Any questions around functions? Any questions from the PPT?
Leela,
happy
yeah,
to-
you can go ahead and ask the question.
So if you look at here, so in general, what we have would be a try-catch block, right? So in that one, whenever we are
Okay.
making an API call, if we get an error, we throw that error.
Yes.
Otherwise, if it is a success API call, then we'll throw the output of that API call. In that
Right.
case, we have to use a union operator here at line number 79.
Yeah, for sure.
Okay.
This
Got it.
is like only I need to explain the type never, so I went with this basic example, but what you said is correct. So if we have try catch block, definitely from try block we'll be returning something for success. So in that case, we should include that in the return type.
Got it. Yeah.
Okay. Any other questions? Or else I can go ahead with classes.
Hi. So parameter can also be never.
Parameter can be never. So what that means is you will be not passing that parameter.
Okay, it means that. Okay.
Yeah. So never, as I said, we normally don't use that much in our production code, but the typing is there. You can have the concept in your mind.
Okay.
Parameter, using type never to parameter doesn't make in that sense. We can, if we intend to make that parameter optional, so we can always put that question mark, the handy question mark as is defined here, but never doesn't make sense.
Okay.
Okay, so we should start with classes then. So classes, as you know, also we explained during object. So classes is like blueprint for any object, like a template. From classes, we'll instantiate the class to create an object of a particular template. So TypeScript also adds typing to the classes. Shashank explained how we can use interface for defining a particular object, but class also can be defined with a particular interface. Also, there will be separate typing in classes for field level. So the first point is around that only. Fields of class can be typed and or initialized. So this small example, if you see, class point, which has two fields, one is X and Y, and there are two flavors of how we type in TypeScript to the fields of classes. So here X is typed as number and Y is initialized to 0. So if I hover over this one in VS Code, you will see that X is of type number and also Y is of type number. So we should be consistent, but here I'm showing the example. So there are these two flavors. You can either type or initialize, or also we can do type and initialize both. For example, Y colon number equals to 0. So that explains like how we can type the fields in classes. In constructors of classes, also we can type as we type in functions, normal functions. So in that way, typing of function and constructor are pretty much similar, but the differentiating factor is the return type. So in function, we can means add typing for the return type, but in constructor, we should avoid that, because the return type of a constructor is always the instance of the class. That means an object. So that is pretty well understood by TypeScript. So we should avoid typing the return type of a constructor. So, and then super must be called before accessing this in the constructor of a derived class. So super keyword we are familiar, right? When we inherit a derived class from a parent class. So we call super keyword so that the parent class constructor should run first, and then we'll call this. We can't like swap the order of on these two. This cannot come before super. So this is a point to remember. And the next is implements clause to check that a class satisfy particular interface. So when a class point implements a type, maybe coordinate. So point implements coordinate, that means all the properties defined in that particular interface should be present in the following class. So that is the point here. Derived classes need to follow their base class contracts, but it may choose to expose a subtype of base class with more capabilities. So this is again talking about inheritance of classes. The child class should always adhere to parent class contracts. And the second point I'll be touching on the example. Soft private allows access using bracket notation. This is also a small feature that I would like to cover in examples. So with that said, I'll switch to classes. So the first example I have is this class point, which I already kind of explained in the PPT. So here you see there are three fields X, Y, Z, and there are three different approaches to initialize or type the fields of the classes. If I hover over Z, it's a number. All of them are number. And when I add the constructor of the class, so there also, this is the syntax of a constructor function. So the parameter, we are taking a single parameter X, and we can actually do anything with it. If default parameter we can assign like we do in functions, or else we can simply type it this way, and we will assign to the field, the X field, whatever we are getting from the constructor call X. So this assignment should be clear. And the next example I have is around the modifiers of the classes. So if I go into this circle class as a field radius, which can have type number, and the same constructor example we are doing here, I missed the typing, but we shouldn't. We should always add that if we know beforehand that it will be of this particular type, we should add that. And the point I can make here is, here we have defined a getter, and we are, yeah. So radius is a getter, and we are returning on the this dot radius field. So, and if I remove this, if we ignore this comment for now, so radius becomes a read-only property. We can't write anything to the radius value. So if we see the error value also cannot assign to radius because it is a read-only property, because we are removing the setter for this field. We have only defined getter for that. When we add the setter, we can always have a value to the radius field, radius property. And this way I initialize constructor, and it will give me an object of type this circle. Circle is a class here, but when I instantiate with the constructor of circle, and I'll get the circle object which will be of type circle with radius, this radius as the property. So that explains getter and setter of a class. Okay, so if no questions, then I can move on to inheritance. Okay, so now we'll go into a example where we'll explore the inheritance of classes. So this is a small interface we have defined here. Animal interface has name, property, and bark method, which can be optional, and this class implements the animal interface, and it should, now that it implemented the interface, it should always have this name property. If I remove it, then TypeScript will be unhappy. So, and also the typing should be consistent. The interface and the following class, those should be of consistent type. I can always remove this bark method because bark can be undefined here. So that can be done here. And the constructor is similar what I explained in the earlier example. Protected, I'll come to later. So this way I am now instantiating the dog class, and I am assigning to the variable Bruno. And now coming to inheritance, this class Husky extends the dog class. So when it extends, it has all the capabilities of the parent class, and also it can add new capabilities like new methods, for example, that can be added. And also it should also adhere to the contract it has made to the parent class. For example, bark method we can compare. In parent class bark method, we didn't have any argument. So now we are introducing an argument. But what happens if I remove the question mark? So this means Husky class has a method bark, and it takes a compulsory argument now, sound. But the parent class says that I don't need a argument for, means compulsory argument need not be there. So I should adhere to that contract, and I can expect that optionally you can give me a sound argument and I'll do something on my own. So when I define it, if the sound is undefined, so I'll call the method from the parent class. Super.bark will call this method, and the log will be oof. And if I pass some argument, when I define this bark, this Husky instance, then I'll call this method if I have sound. So I think that explains, like, the child class always should adhere to the parent class contract. It shouldn't violate that, and it can always add new capabilities. So yeah, this is how inheritance works in TypeScript. And there is another concept of protected. If you see the name here, so I didn't assign any modifier to this name field, so it is always public. So there are other modifiers in TypeScript like Java. So there can be public, private, protected. So private is more or less similar how we have in JavaScript, but the syntax is slightly different. In JavaScript, we'll explain it this way. Private maybe something is vegetarian maybe. So In JavaScript, I think we do it this way, as, but in TypeScript, we can make use of the keyword private. So that is a small difference. So I deliberately ignored that. But protected has some feature to talk about. So if I introduce protected and the field is pet, and again it is a Boolean field. So now dog has this protected. So this protected cannot be cannot be accessible outside this class, but it can be accessible in the child class. So if I instantiate here, the dog class I have instantiated to Bruno, to this variable, and I am accessing Bruno. Sorry, I'm getting typo. Yeah, Bruno is pet. See, I'm not getting any intelligence because it is a protected field. But I can always access this inside the child class. Yeah. So child class also I can access it, but there is a caveat here. So in parent class it was protected, right? But in child class, what I'm doing is again I'm assigning true to it, and I'm removing that protected. So now it no more remains protected property. It is now a public property. So now you see I can access it like a public property. So if we intend to keep this protected, so again we have to add protected keyword here. Now it will complain that it is protected. So this thing can be kept in mind while we write some production code and we make use of inheritance. Protected field should be marked again protected when we are accessing it inside any subclass. And if we intend to make it public from here, that is fine. That is the use case for this. Also, I'll like to add here. So if we see this my pet, we are instantiating this child class husky. So dog is the parent class. So if I hover over my pet, it is of type husky, the child class which we are instantiating. But it should always adhere to the parent class. Let me comment it out. Yeah. So now this is also applicable, right? If we think logically, husky is a child class. We are instantiating and we are creating a child object. But dog is the parent class. The child always should implement the basic features that are given by the parent. So it should always comply with that interface as well. So this is also we come across in many cases in production code. So this is also pretty much fine. We can do this. If some error comes here, then there is some problem with our inheritance. Any questions here? Anything related to class implementing inheritance in interface, inheritance of class? No? Okay, then we are good to go with generics. So generics is a pretty cool feature, I would say, in TypeScript. So what it stands for is reusability of code. So many times we implement interface or type aliases to define our particular variable or particular data structure. So in that case, generics actually helps, like we can reuse the interface or the type aliases we have, so that we'll have reusability in the code, and also the code becomes much more readable when we make use of generics. So the definition goes like this: a kind of tool that enables you to create reusable code components that work with a number of types instead of a single type always. So this is the point to remember. So this is the like syntax. So inside two angular brackets will introduce some variable. For this matter, type is the variable. So parameters are for relating the types of multiple values. So consider this type inside these two angular brackets is a variable, and it can take any type, data type. So it can take string, it can take number or object or array, anything. So that will decide when we use that particular interface, we'll pass some value to it, and the whole interface will be complying with that. So we'll see some examples around it. But before that, I'll like to finish this concepts. Type parameters can be constrained with extends keyword. Yeah, again, the capability of the generics can be constrained using this extends keyword, so that will make a means constraining contract, and the type should always comply to that contract which we are defining with extends keyword. There are bunch of benefits using TypeScript, using these generics in TypeScript. We define a relationship between input and output parameter types. Normally, there are many utility functions where, depending upon the input type we get, our output differs, right? So in that case, we no need to type it with multiple union pipes like string or number or blah blah. So instead of that, we'll make use of the type, and we'll simply define the value of the type variable, and we are good. Stronger type checks can be obtained with generics. Some unnecessary typecasts that can also be removed with generics. And the other benefit is we can the feature I didn't talk about is when we defined a type variable inside two angular brackets, we can always add a default value of the type. For example, type can be a string, like most of the cases. So I can do that, but I can also omit that default type. So let's go to the examples. There I can explain better it. Okay. Yeah. So I'll start with this simple example here. So this identity function takes an argument and returns it. There is no much logic inside the function body, but for typing purpose, if you hover over this, so what we are getting is argument is of type any, and the return type is also any. So what it means is, if I use this function somewhere, id maybe, and I'm calling this function and I am passing this to maybe some string. So what we intended is, when I pass this argument, I should get string here, right? Because what will it do? Bond will be assigned to this argument, and the return type will be bond. So the return type becomes string, right? But what it did is, TypeScript has no clue what the return type is, and it simply assigned any to my ID. So this defeats the purpose again. So to type it better, instead of keeping it like any, what we can do is, you can do string. So now ID will be string, but the problem is it will always take string now. What happens if I pass some ID? I can do that. If I do number and the same thing, I'll also cast to return type. Now it will be confused. So the ID will be string or number, not number in this case. It should be number, right? In this case. So the intention of this function is whatever we are passing to the argument, it should always return the same type to us when we call the function. But it cannot do that in this way. So the ideal way to do it is using generics. So what I'll do is, sorry. So I'll introduce a variable here. And now the argument, if the argument is of type T, or for that matter, I'll write type full. If argument is of type, if a particular type, and the return type should also be that particular type. And but TypeScript doesn't know what type is, so we'll introduce generics here, the two angular brackets and some variable. So now TypeScript will be able to infer the type of the return type. For whatever the argument type is, that will be the return type. Now if I hover over this, ID is 10, it is able to identify the return type correctly. So it can be applicable for any, if I say some object, it will be of that type. So you got the point here, right? So type is a variable. We can assign any default value to it. For example, type can be string. So if I don't pass anything, it will be a string. Otherwise, if I pass something other than string, so it will be of that type. So this is the very basic example of generic function. If you go to the TypeScript official documentation, there also you will find the similar example. And they call it as hello world of generics because it is very basic. So yeah. So this is the essence of this example. The generics, how the type capabilities are consistent across the function body. So going to some better example. So I have this list element function where we are defining the generics, and the argument is like kind of related to the type we are passing here, type array. It is a array of type. Type is not known during this function definition, but it will be known once we execute the function. And also the return type can be of type, or it can be undefined. So the function body also I have defined here. We are simply passing an array and an index. And what the function does is the particular element in a particular index it will have. So if I pass 0 as the index, it will give me the first array element. So when I go to the use case of this function, so I can call it this way. List element I am calling, and I am assigning number to the type variable, and I'm introducing, means I'm assigning the array to the first argument and 0 to the second argument. So now I'll get number or undefined. It should be number ideally, but the example is like that. What if the index becomes 10? In that case, it can be undefined, right? Because the length is 2 and we are interested in the 10th element. So for that matter, I have kept undefined here. So this is not the only way to make use of the function where we define the generics. We have also this example where we first pass the argument without explicitly mentioning the type variable like we did here in number. So from here, TypeScript will infer that it is of type, it is of a string array type. So string will go and sit here for this type, and the return type will be string or undefined in this case. You see, string are undefined. So this is how generics is very useful in our code. And it introduces the reusability of the code. List element now can be anything. And TypeScript type assignment will be accurate. So this is again a similar example where
Hi, I have a question here.
Yeah,
Not
yeah, sure.
completely related to this topic, but
Okay.
something related to the arrays concept that you spoke of. So
Yeah.
whenever I'm trying to access the array with an index, it always complains that it can be undefined as well, right?
Array.
So there is an
accessing-
array A
Yeah.
and it has 4 elements.
Okay.
Now I'm trying to access A of 1, array
Okay.
of first index. At that time, TypeScript will complain that I should not like the variable, like if I replace 1 with some any other variable,
Okay.
1 with any other variable, not a variable like index or some other name,
Okay.
then it will always complain that id cannot. So you right now you got that information.
You mean this one, right?
So it will always complain me like it would be undefined or something. So it asked me to check something, or it asked me to check greater than the length of that array. So is there a way we can avoid that check by default?
But for this case, if this like mimics what you want to say, if I have an array and I have an ID variable and I have assigned 1 to it and I am accessing that particular index from this array, so I'm not getting any error here.
Okay, can we try it in a for loop?
Okay. I think yeah, we have time, but yeah, let's do it quickly.
So this type of scenarios I generally encounter when I'm trying to access a particular this thing. Not sure why it was exactly given.
So here also, if you see, now I am making use of this I variable instead of this ID. So now it will be traversing from 0 to a dot length, right? So what's that issue you are facing?
I'll just check my code and then I'll share some
Yeah,
feedback
you,
with you
yeah,
such
yeah,
that
yeah.
we can discuss at the end.
Sure, sure, sure. Yeah,
Yeah.
you can keep it in the chat and we'll come to you.
Sure. Thank you.
Okay. So yeah, this example here also we are making use of any, but we can always type it to two different types. For example, T and S, and the first argument will be of type T, and the second argument will be of type S. And now if I remove this also, that also fine. But when I hover over this one, get list will be of type, the return type will be of this type. So here I am introducing two type variables instead of one we just saw. So T and S are placeholders of the type variables, the name of the type variables, and we can assign any type. For example, we can assign string to the first argument and number to the second argument. So this way it works. And yeah, with extents, we can always limit the capability of the type. So if we see the particular function body, first we'll take a look at the function parameter. A and B are of type. And what we do inside this function body is, if A has greater the length than B, then it will return A, otherwise it will return B. So if we see here, A dot length means A should have a method called length, and B also should have a method called length. So when I am defining the type variable for this, it should it should have this contract in it. It should always have this particular length property. So the type for this matter should always have this particular type. then we'll be able to execute this function without any error. So type can be an array or can be a string, but not a number, because number doesn't have this length property, or it can always have an object which has this length property defined. Is this clear? Constant types here. I hope it is. Okay. So
Sachin,
yeah.
On line number 43, you showed, yeah, So
Okay.
here, if we want to return something which is of type R, so what could be the syntax? Like, see, T and S are argument types, and what
Okay.
we are returning is of something different than T and S. Like we are entirely creating a new object. Okay, so we need to.
Yeah, you can do that.
And in function return, in the syntax of the functions declaration, should we add like colon and R there, or it's?
Yeah, we can add that. You can, yeah.
Okay.
But
Okay, so
here you have to add this way, right? Because now R is a different type. The default return, the unconditional return one is of this type, T or S. And this is something returned that we are not very sure which should be of this type. So, but yeah, we can
Okay.
do this way.
Yeah. Okay.
But
Understood.
when you are introducing type variables, right, you should look out for the reusability. So here, if I see for this basic example, at least T is I am making use of a variable, S I am making use of, but then there is no sufficient use case to introduce another this type variable, at least for this basic example. So here I can always go with some simple data types. But yeah, coming to your question, the return type can be of a separate type variable. That is also possible.
Okay. Okay. Understood. Thank you.
Yeah. So we'll go to generic class also. In class also we can define generic, and this box class has this T type variable, and the content field inside it will have to will make use of that T type we are assigning when we create an instance of this class. So this is more or less similar. Interface, again, we can make use of generic type variable we can introduce, and the inner methods and inner fields can use of that type. See here why I introduced generic is normally why we should introduce generics is there is a case of reusability here. The array what we define will be consistent, right? If this is a number, then this also should be a number. So this reusability, I can take a common and introduce generics here. So with that, we are done with generics, and any questions, feel free to ask. Next, we have utility types. Those are also in line with generics. We are making use of generics, and we are introducing some utility types that we can use in day-to-day coding. Any questions around this? Okay, so we'll go to utility types. So these are bunch of like predefined utility types from Typescript official documentation, and the definition is like globally available types to facilitate common type transformations that we do. So very useful again, and we'll see in examples. These types are themselves strongly typed and have specific use cases. All of them stand for a cause, and when we encounter that particular scenario, and we'll definitely should leverage the utility types that are defined. it saves time of creating custom types in our coding. So we don't need to come up with our own name and define a generic and then making use of that. We can always make use of these predefined types. Similar, the last point says around that. So I'll go to the examples quickly. Yeah, so this car interface over here, these are bunch of properties, some are optional, and this is a utility type which you make use of this pipe operator. So that is already explained. So now we'll talk about the past utility type that we have, partial. So partial is a utility type that returns an object which will be a subset of the given type. So the syntax is partial, and in the Angular bracket we'll will add some interface type. So for example, here car A is of this type. So this is a type for TypeScript, and it will convert to a particular type for a car A. What will that type be? So it will take car as a type. The partial will take car as a type, and it will make all the properties inside car as optional. So the parent car has two compulsory type, if you see, brand and model. But when I define car A now, I can define an empty object, and TypeScript will not have any issue. Got my point? So if I remove this partial here, so then I'll have some issue because I'm not defining brand and model, because these are not optional. These are compulsory. So partial helps us in that way. So again, the reusability is there. The interface car we have defined once, but we need some typing which is around that, but we need all of them to be optional. So I can have only name inside it, and that should be fine. The name string is not assignable. Achha, sorry, name is not there. My bad. Okay. So any property you can assign, but that is not compulsory. So coming to required, it will return all properties, and the all properties of that particular interface we are passing into it. It will make all of them to compulsory. So now if I define car B, which is required car, so if I only leave brand with car B, then it will complain me. So it will complain that model, color, and these other properties are not defined. Why? Because now all of them are compulsory. We can't leave any of the types which are defined here. So in this way, required is helpful based on scenarios. And also read-only type, it is also like basic object.freeze feature of JavaScript. The properties of the return type cannot be reassigned. So car C, if I hover over this, is declare, okay. So we can't, once we define it, we can't change. That is basically around that. Model is missing. Why? Because model is also a property, a compulsory property. So now I think if someone comes and someone tries to remove the brand property, can't do that. It's a read-only property. So this is also a handy utility type in that sense. So object.freeze feature basically, but with generic we can achieve this capability. Now this is again a super useful utility type that we use most often. Record. Record has two type variables in it. One is keys and the other one is type. So it maps the properties of it type to another type. So how it does is, it will take it will take a utility type, union type as first argument and maybe an interface as the second argument, and it will create an object for us for car D. If I type car D, and what I can do now is the car D is an object. The key can be any of these three car brands. So for example, let's say Tata, and now I can assign the features of the car, means the value to this Tata property. I can define using this car interface. So again, brand is Tata and model. Sorry for this. Yeah, missed some quotes. Yeah. So I have some issue. Car is missing the following properties from the record. Okay. So car brands has three car brands in it, right? It's a union of three strings. So it should contain all the properties, like Mahindra, Maruti are missing right now, but we can we can do these things. So it is very useful when we want to define a type, but not from scratch, but we have some type as which we can use as for example, the keys as keys of an object, and the value we can make use of something. So in that case, we can make use of we can create a type instantly with our existing types. So I think that should be sufficient for this. I am still getting some issue. Car D.
You haven't changed with the Maruti third.
Yeah, right. Yeah, thanks. Yeah, see, now I'm complying with this type here. So record is for creating a type on the fly, making use of the existing types. Peak also is similar. It returns a subset of type consisting properties part of keys. So it is like cherry picking some of the properties right here. So from car interface, I'm picking color property, and now car E should have that property. So see, so car is should have this color property by any case, because car in itself has color optional, but with peak utility type, we can make use of the car property, car interface, and come up with a type where we define that color should be there. So that way peak is useful, and omit also like opposite of peak. So here what we say is from car interface, we want everything but not color. So we can have brand, we can have other model, electric, mileage, but not color. Color should not be there. I think that explains. And exclude, returns exclude takes a union type and the member which we want to exclude. Similar to omit. Omit we already explained here. Returns a subset of union types excluding the assignable to type assignable to excluded member. So again, car brands is a union type which will have Tata, Mahindra, Maruti. But what we want is we want to exclude Maruti. So now car G will be Tata and Mahindra, not this excluded member. Extract again, car, we have car brands as union type, and we want to extract only these two. So if I hover over, I return subset of type with types assignable to union. Okay. So car brands, we have Tata, Mahindra, Maruti, and we want this particular set, which is like common to this that we need, that we want to exclude. So here, if you see Suzuki and Tata are excluded. So what remains is Mahindra and Maruti. Tata is excluded, Suzuki was not in the car brands. So it is extract. Okay. Yeah, I think I explained the opposite. Tata should be picked. No, Suzuki is not there, and other two are omitted. Now these are, I think, we no need to like make them by heart, but depending upon the use case, we can always go to the official documentation. There is a well explained particular page in that documentation, so we can refer that. This is a simple example, make car. So this is a function, and it will have two arguments, and it will return a type, return a car maybe. And to why I introduce this function is like there is another utility type of parameters. So where I can pass in a function and I can expect that what are the arguments list, those types I want to be assigned to this variable. So here if I see material is of type string, color is of type string. So these will be assigned to now this. See, it will take basically any function and it will extract the types of that arguments of that particular function, and it will assign to the variable you want to introduce. Similarly, a return type will also take a function, and the return type of the particular function will be assigned to this variable. So car A is of type partial car. So now the car Z will have type partial car because the return type matches. So these are these two utility types that takes function as an argument. So we can directly use function because function is a variable, means it has some value, but it is not a type. So we make use of this type of operator so that it extracts the type of the function, and then parameters will extract the types of the parameter list. Yeah, I think these are the most used utility types. And any questions here, feel free.
So Sachin, for record type,
Yeah.
how can we say like this car D will have any one of this brand, like not all three?
Okay. So any one of so you mean
Yeah.
any of them, right? Tata or
Yeah,
something.
record could be a Tata or Mahindra or Maruti and not all three. So
I think we can make use of this way. If I know that Tata will be there only. So
no, but it could be Mahindra or Maruti as well. But
We can
we
use
want
a
to.
partial, I
Sachin.
think.
So
Yeah.
so we can use
Okay.
partial. So partial of car brands you do, then you can put one or two or three or any of those properties. So that partial basically adds the optionality to the car brands.
Yes.
Okay.
So
Yeah,
car brand
that-
is a union of three types. Now we can have any of them.
And in this case, if we provide some different brand, Suzuki will get the error, right?
Yeah.
We need to have. Okay.
Yeah, for sure. Yeah.
That's correct. Thank you.
Yeah. With that, utility types is covered. Now I think Prabhu will take over. Over to you, Prabhu.
Yeah, hi guys. Thanks, Sachin. That was a good session. Okay. Hope you all can see me. Sharing my screen, let me know. Yeah.
Yes.
Yeah. So yeah. So basically, I'll cover type manipulation So basically, we have two types of two major concepts that in this type manipulation that will help us write a proper modular code and clean up our code when dealing with these types. So two of those are like conditional types and map types. So conditional types are basically like similar to conditional expressions in JavaScript. You're just dealing with them at a type level instead of value level. So they let us do type transformations and create newer types based on our generics. So I'll explain that in examples. So that is one form of type manipulation. And we have map types. So when we want to derive a type from an existing type, we can use map types to keep our code in dry state instead of creating a similar interface again. So we can use these map types and programmatically we can derive that type. So it helps us keep our type definitions that are dependent on each other in the don't repeat your code state. So I'll directly go into the code. So before I go into this conditional types or map types, I'll just briefly give an overview of type operators. You might have already known this, but if suppose we have a type point and it's a keys or number and number to extract the type of the key, we just do a key of point operator. So if you see that, you'll get a key. So this key of is generally applied to a type so that we can get a union of all the types of the keys that it has. Okay. So basically, and I don't know if Sachin covered these utility types. Suppose we have a function here, and if you want to extract of the return type, we can just use this return type utility type. So this is also one of the utility types that you need to, that is very useful. And yeah, and suppose here take type person for example. So we have a type which is, so we could have defined this as interface also, but for use case here I'm using type. And yeah, so here to extract out a single type, so we can also use the access the key types in a type. So suppose take the person here, and if we use the age or name key, age or name, so we will get the union of the number or string. So we're accessing the types of the keys in this person type like this. Cool. Similarly, suppose we didn't have this person interface, we only had this object which follows this blueprint. How do we get the same thing? Okay, so this is where our key of and type of operators come into help. So basically, first we have to get the type of this object. So we get the type of, okay. And as I mentioned, we apply the key of to the type. So we'll have, so we get the type of object and then apply key of. So in that case, we'll have all the union of the key names. And again, we create a type of object of that, and we'll get all the types, union types. So our age is a string, our name is a string, our age is a number, and our alive is a boolean, right? So if you have to extract out the types of all the property values from an object, we could do it in this way. I hope this is clear, right? You don't have any doubts here, correct?
Can you repeat it? I haven't quite understood.
Yeah. So 1 second. So suppose we had an object here, okay? So our goal is to extract out a union type of all the value types for our properties. So we have the values, right? We have age property, name property, alive. So all these three are of different types. This is a number, this is a string, this is a boolean, correct?
Yes.
So in that case, we have a use case where we have to extract out union type of these three properties. Cool. So X. So in this case, how do you do it? So we don't have this person interface. If you had this directly type, okay, you're dealing with a type. Cool. You can directly index, use this index operator like this. Correct. So if you see the person is already a type, and if you do the index age or name, you can get this. But right now, so initially, let's do this. What is this? So this gives us the union of all the keys. Cool. So we're we're extracting out the type and the keys. So it gives us all the keys. So what we are getting is this. Okay. So now if you want to get the value types, you just so you just do the type of object, which will again give us the blueprint of this object, which is the person. So you can extract out these things. Cool.
Yeah, got it.
Yeah.
So
Yeah,
basically, the object is the person here, and
Yeah.
that age and number is the key of type of object,
Yeah.
So, okay, got it. And
Yeah.
from
So as
that, we are extracting the person ka keys each value. Okay.
yeah. So I picked this use case to demonstrate in case we didn't have a type or interface, which is with us already. All we had is a data object in our file. Okay. And if you found a use case where you have to extract out the types of the values of the properties or just the keys, you could do it this way. Cool. So just the use case of how to use key option type of to extract out types from actual values instead of types. Okay.
Yeah, got it.
Yeah.
Prabhu, one question.
Okay.
On line number 31, can we use pick here, like where you are taking properties of
Yeah.
percentile? So that syntax is exactly similar as pick, right? I think you commented out person. So
Mhm. Okay, sorry.
no. So,
So this will give us the object. Okay. So interface, so partial interface. So if this is like, so this is the object,
okay.
right? So so if you pick or do it a partial or like, so pick if I pick one more here. Okay. So age and name. This will give us this will give us an interface
And
which
then we might have to do key off on pick.
yeah. So
Maybe.
most of these utility types return this interface. So
Okay.
so keep that in mind. So initially so in scenarios like this key of type of operators come into picture. That could be very useful. Okay.
Yes.
Okay.
Thank
So
you.
I think that is enough on this. I just wanted to explain that before we go into map types. So as I explained, right, map types are basically if we have one type and we want to derive another type which is related to that, we can use this map types. Suppose we have a type. Take this feature flags. Okay. So this feature flags is a type which is dark mode and the two variables which are functions. Now we want to have a feature flags variable, okay, which has same properties, but the type of those properties is booleans. Okay. So then we can define a. So I want to keep in mind that all the generics and utility types such and such that Sachin has gone through, so that you can understand this better. So we are defining a generic type here. Okay, option flags which takes in a type. Okay. So now we are looping. So if you see, I'm using the key of operator here. So our key would be, or like the properties would be in key of type. So whatever the type we get, our properties would be, we are taking the keys of those, and for those we are assigning the boolean type. So we'll have a new object with the keys of these types, but the type of those keys are boolean. Okay, instead of whatever the functions have. Correct. So if you see here, I'm taking these features flags. I'm options flag of feature flags. So if you see here, our feature options would be dark mode boolean, user profile boolean. So we are preparing a type which is related to our feature flags. Okay, using a map type. So we finally got this one. So you understood this part, everyone? I hope it's clear. And we have so this is one use case of map types. So and we have other use cases as well. So if you wanted to, suppose we have a type which is a read-only type. Okay. So we have a logged account which is a read-only two read-only properties. Now we want to create a type from this which removes this read-only types. So if you see, now we will create another generic type, create a mutable of type. So we have these two operators, minus or plus. So we can remove or add the read-only and optional properties by using these modifiers. So in this, so whatever the read-only properties, so we from all the keys of the type, we're removing the read-only. And so if you see the property in key of type, and we are again taking the type of property. So here, if we do here create mutable of logged account, you can see unlocked account is a, we remove all the read-only properties and we just create a mutable type. So I can get I can understand the syntax might be a bit tough and tough to understand while explaining. But if you have any questions, just raise and we can walk you through. Okay, so now next important part is the conditional types. So conditional types. And yeah, so here when Sachin was going through functions, right, you saw like overloads for functions. So a function had overloads. Suppose take this create label function. So this create label function has ID. So these 3 overloads, and this is the implementation. So someone asked if we can have the same implementation and the overload in the same file. Yes, we can, because these 3 are declarations, these declarations. Now, if you see, now we can get a function implementation is missing and or not immediately following the declaration, because we are just only declared it, but not implemented. So just for example case, we implement command this, just through unimplemented. So now basically these overloads are like describing a single JavaScript function that makes a choice based on our input type. So all the code that would get executed would be from this implementation. But when we're actually using this function in other files in other places of our code base, and if we pass a number to this function, okay, then TypeScript would notice this overload, and there we will have a return type of this ID label. Okay, so that it will help the return type instead of dealing with union types, because dealing with union types could be messy. So we want a specific return type. So we don't want to we want to avoid union types as much as possible in general. So that is I just wanted to explain that because someone had asked, I think Sunil, a question regarding this. And now into the conditional types. So how can we improve this? Suppose we have an npm package that has library, that one function which has a lot of use cases and which can take in a lot of parameters depending on the use cases. So we'd have to keep on increasing the overloads here. We'd have to keep on adding new overloads, which could be really cumbersome. So now this is where conditional types come in. So we use the conditional type with the generics. So because as Sachin already explained, right, we can use a generic here and make that. But along with generic, if you use a conditional type, which is this, if you see here, name or ID, this is our type we are creating now. This is generic type, T extends string or number. So this is already a constraint. I think you can understand this. So we are limiting our argument to our name or ID type to be a string or number. So now our conditional type is this. So if T extends number, so the argument that we pass to this generic type is a number, our return type would be our type, the value of this whole type would be ID label. If not, it would be name label. So the reason we are doing is, if you see this create label function, when we are passing a number as an argument, it returns ID label. When we are passing a name string, it returns name label. But we are having to define 2 overloads here to show that fact. But if you use a conditional type, you can do it here like this simply. So we are creating a type name or ID which takes in a T, which has a constraint. And this is I can explain the constraint. If you are trying to use this name or ID, just in case you have name or ID with a boolean. So this shows, okay, type boolean does not satisfy the constraint string dash number. So this name or ID can only take either string or number. Otherwise, you'll see an error. Just in case if you haven't understood this extents clearly. So now is the main part. So now instead of using all of these overloads, you can cut it down to a single implementation along with a single declaration itself with a generic. So if you see our create new label, this function is a generic function. It extends T. T is similar to this, and our ID or name is of T. And now our return type we can annotate using this conditional type. So name or ID of T. So now when we use this function, if our T is number, and our return type would be ID label, because our return type is a conditional type. And if the T extends number, it will be ID label. If the T extends string, it will be name label. So basically our return type is now a conditional type, which will be adjusted based on the generic here. So we have avoided creating these multiple overloads in our files. Okay. So this is where the power of conditional types comes in when you use them with generics in scenarios like this, which have return types which are dependent on the argument types. Is that clear? So that is the gist of how a conditional type works. Do you have any doubts till here? Anyone? Okay, I hope then everybody understood this. I'll move on. And yeah, so again we have a few other cases where, well, okay, yeah. Suppose we also have an infer keyword in this conditional types which we can use. Okay, so suppose we have another type flattens. Okay, so it takes a type, and if T extends array of infer items, so this infer keyword we can use it in the true branch of our conditional type to actually directly get the item instead of trying to get it out of the type. So for example, if you see here, same type I'm defining, flatten T. So if this extends an array, we are trying to do T of number. So this is again we are trying to access the type of the index. Instead of doing that, so we can infer it. So for example, here our flattened array takes this and it infers the item, and we can directly get it. But if our T is not an array and it does, if this condition fails, then we will be never. It will be never. So basically, we are defining this type to make sure that to extract out the element type of an array. So you can use this infer keyword on it inside a true branch of a conditional type. So you can use it, for example, like this as well. So get return type of a function. So suppose we have a function and we want to get out a return type of that function. We want to get it. So now we can use this conditional type. So our tx, if the t extends arguments of never, that is fine. And we are using the infer here. So basically, we are creating a variable, okay, return by inferring, and we are using directly again it here in the true branch. So for example, we have a function here. Okay, we have a function type, and if so from function type, we can use the number type here. So the number type will be extracted out because we are inferring the return, which is the number here. So similarly, the string here, the string type would be this, like that. So we can use the infer also. So basically, keep in mind these two. So it helps in like reducing the overloads when we use it with generics and use our return types and condition, and also you can use the infer keyword. So these are the two major things that you have to keep in mind, and you can research more about this to get more clarity on how we can use the full power of conditional types. Okay, I think and one more small thing I want to cover is template literal types. I think you might have already known this, but so this is a relatively new feature in recent versions of TypeScript. So for example, we have a type. So we like strings can be types as well, right? Our world would be type. Our world would be of type this one. So now greeting, we can use this, like we can use template literal types. So we are creating a new type called greeting, and our greeting would be a string literal type. So if you see, we're using basically we are using a string literal, and instead of an actual value, we're using a type here. So we can create new types from existing types using this template literal. So that's why it's called template literal type. So our greeting would be of this now. Okay. So if you have a greet, now this would throw an error because type hello is not assignable to type hello world. So our greeting is a strict string, which has the hello world. So it can only be of this string. So we can't assign any variable which has a type annotation of greeting. Has to be hello world, not any other string. So like that, we can restrict some of our data by using these template literal types in few scenarios. That would be helpful. And yeah, so similarly, you can see here there are two union types, and so if you are doing this, or resulting type would be of this. So there are like multiple use cases like that. And so we're running out of time, so I don't want to go into all the details, but yeah, keep in mind that template literal types can also be used. This is a new feature in TypeScript. And now I want to go through decorators. Most of you already, so decorators are basically syntax that we use on classes, which will give us additional functionality, right? So you see here. So basically, decorators are still experimental, so they are still in a stage to proposal for JavaScript. Okay, so they are not full-fledged feature. In the future, some of the functionalities revolving around this decorators might change. So keep that in mind. So yeah, so these decorators we can use by attaching to classes or any property in class, declaration, accessor, parameter. So I'll briefly explain you like how we can use these decorators in TypeScript. So one thing to keep in mind is, suppose take this class boat. So we have a property, accessor, and a pilot method. Cool. So now we have okay, let me just remove this. Yeah, so the decorator syntax basically goes like this. So we have used the red sign, and we have so decorator is basically nothing but a function. So whatever you keep it here should be a function. Okay. So this function will get called when the class is ran. Okay. So not when the instance of a class is created. So that is one of the main points that you have to remember. So only when the class is executed for the first time, that is when this decorator gets ran, and add some additional functionality to whatever the property that you have assigned this decorator to, not when the actual class instance is created like this. So basically we have this log error. So so take this pilot for example. So this throws an error. So for simplicity, we are just throwing an error, but we in our actual production code basis, we'd have a lot of functions in classes in which certain cases they throw errors. So how to deal with that? So we can come up with a decorator here, log error. So here in this case, this decorator has 3 specific arguments. Okay, so these 3 arguments are so come up with this syntax. Okay, so when you use this at the rate sign, it will, and whatever you put here for that function, these 3 arguments will come: a target, a key, and a property descriptor. So basically, the target would be the prototype of this class boat, and the key would be whatever the property or method that you assign this decorator to. And the property descriptor I will explain you guys shortly. Okay, so 1 second. So many of you know property descriptors already, or have you heard of what a property descriptor is? So property descriptor is basically an object which object that helps us configure a property in our objects. So I mean that might be hard to understand, but I'll just explain. Suppose there is an object here that I'm defining, and it has a name property, which is Prabhu. Okay, age. Okay, so now we have a special object called property descriptor, which gives us some configurability to our properties that are defined in an object. Okay, so if you to get that, you can do object.get own property descriptor, uh, the object the name, and the property name that you want to get this descriptor for. Okay, sorry. You see here, there are, so if you see here, there are 4 values. So what we did is get on property descriptor of property name in this object person. So what we got is a configurable property which is true, enumerable property which is true, and the value which is Prabhu. So because the value of the name is Prabhu, and writable true. Okay. So this helps us configure. So now suppose if I change this property descriptor, okay, suppose take this example, writable, for example. So writable is true, which means that you can change this property. So now person dot name, right? So now the person would be this. So now we just changed it, right? Because this writable is true, we are able to change it. If this writable were to be false, you won't be able to change that value of that property. I can show you that. How you can modify this property descriptor is define property, the object, and then the name of the property, which is name again, and the configuration. So what you can just, whatever you want to mutate, you can do it. So now you see here, object.define property person. So and the name for this property, I put the writable as false. So now just to double check that this works, if you see writable as false. Now if I change, so now our person is the name property is Yadav, right? Just to be clear, this is Yadav, right? Now if you try to change it back, name, it looks like it changes, but it doesn't. Log it again, you see this is still Yadav. Okay, so this is the key concept of property descriptors. This is just a configuration object that will give us some authority over the properties that we define in an object. So this is what gets passed to a third argument as a third argument for this decorator. And this is what we use mainly to actually modify or add some additional functionality to the properties that we, because these are all properties, right? Pilot, book color, formatted color, all of this is both class is nothing but a syntax issue. Internally, this is just an object. All of these properties are on our prototype. So our prototype gets us the first argument, or key would be that. So now if you see this function, so now the description dot value. So this is the property descriptor. Descriptor dot value gives the method itself. So whatever the pilot we have, because if you see here, I was applying to name. So the value would be that. whatever the value is that. So in the same case, the method for the method, it will give that function itself. So now, okay, so we got the method. So now we are actually changing the function. So if you see here, for description.value, I'm assigning an entirely new function. So what this does is, we try this. So we are using a try catch block. So in this try catch block, we try to execute this method, which is our main pilot. Okay. And if any error occurs, we are catching it. Okay. So now, by applying this decorator to our property, to our method, we've essentially changed the functionality of how it works. So we've added a error catching block using this, by changing this value, because the value property of the descriptor is what the actual value of a property is. Okay. So now if I can run this, you see here, since we are throwing error here directly, we'll have to log this message, because if you see here, this console.log message is nowhere in this actual implementation, right? So I'll run this file. Okay, first, before that, I'll have to call this method, because if you see printed message, because immediately we are throwing error, and our actual function is now this. So when we call this method, we catch it and we throw this log. So basically, this is the use case of decorators. So basically, now we have a log error, right? So any file, you might have a lot of classes in your code base. So any file that wants this custom functionality of catching an error that might occur in that function implementation, you can just decorate it using this syntax, and then you will be able to add that functionality. So like that. So now here I'm using a hard-coded message. Now, if you want to actually customize it, so if you want to customize it, you can create a decorator factory. What is what you call? So what the decorator factory is? So now, message thing. Bear with me here. So now we just return this function. Yeah, keep in mind that our decorator should always be a function. So now when we call this log error with some message or some, oops, this is a board class, board plus some, right? So now we can directly use this message, customized message here, like that. So now we created a decorator factory. So initially when this gets called, this, so as I mentioned, so that is an important point to remember. The decorators will only get called when the class is ran, not when an instance is actual. Because if I remove this, okay, this is a method, right? Wait, let me just log in. Yeah, so now we are customizing the decorator. So once we call this log error of function, we return an anonymous function. So this will get executed when the class is run. And so the next time when we call the pilot method after making an instance, we'll get that message. For now, you'll only get the pilot, which is the key. So which is the second argument, because we're applying decorator to this. And now if we do this, we get the key, and also both was sung, because when our decorator ran, this code got executed and our function value got modified. So this is our new function. So that is basically how these decorators works, and how the property descriptor makes decorators helpful in our projects. So I mean, were you guys able to understand that? If you have any questions, maybe in the chat. Anybody? Any questions on this?
Hello, Prabhu. Yeah, sorry, you might have explained it, but what will be the exact use case of this decorator? I understood the concept, but in the project where. Mhm.
Yeah. So suppose you have when you work on a backend, right? You have a lot of classes which would define an API. Okay. So you and similarly, this is log error decorator is there, right? So as I mentioned, suppose you have multiple methods where there are cases where errors might be there are possibilities of errors being thrown, or like, right? So it could happen. So if you want to if you application wide, if you want to catch that and display somewhat similar message, okay, now you can use this decorator. So you can define this decorator in your application, and you can apply it to whatever methods with this customized message, okay. And whenever an error occurs in that method,
Yeah.
this will get executed, and you will log that, or you will do something with it. Or this error also you can use something like that. So basically, this adds a additional functionality, count functionality that we can use across our project.
Okay.
So that's why a lot of libraries like Nest.js, if you see Nest.js is a backend, it's like upgrade over Node.js, which is written in TypeScript. It has a lot of decorators that you can use. It's a lot of built-in decorators that you can use and validate and apply to your methods in class to give you additional functionality. You don't have to write all that functionality by yourself or declare, define your own decorators, because they can be really helpful in the situations to avoid common code.
Yeah.
Right. Yeah. So we don't have to do try catch every time in every method. If you have 10 classes and 10 methods like that, you can just use this decorator and give custom message. If error occurs, it catches and locks it.
Okay, so to put some cross-cutting functionality like
Yeah.
common through the project. Okay.
Yeah, common through. So
And
it adds.
and decorator really like it's just like when the function gets executed, the surrounding part of it gets executed and gets logged. It's not like decorator is going to run the method itself, right?
No. Yeah. So when the class gets executed, this decorator will get called, correct? Only one time. And one time, at that one time, it will change this definition of the function, right? So this descriptor dot value is, as I mentioned, this will change the function. So this is our new pilot function. So whenever you create an instance new boot and create a pilot, okay. So
Yeah.
at that time you will see the result.
Okay.
That's why, as I said,
Yeah.
right? If I commented this, okay, and if you remember, that's why I added this log, console.log key. So when our decorator gets called, this will get called, but this console.log key, you can see the result.
Okay.
Pilot. Okay. Now I think the comment. Okay, I haven't saved it.
Yeah.
Sorry.
Yeah. No,
Same thing. Yeah. So now
Yeah.
you'll only see pilot, but if you actually our definition, when the decorator and our definition has changed, to see the results of it, you call an instance, create an instance, and
Why I ask? Because if we have put a decorator over the function which is creating a record in database, so we don't want like while it gets compiled, it creates a record. We want
no, it won't.
Yeah.
So so basically when you're defining a class, right? So it's like just adds additional functionality on one time. So
okay.
As you saw, right, when we ran, even though when we didn't have an instance, it got executed. So it only executes once. That is very important to keep in mind. And so by this way, I've only demonstrated you using decorators over a method, not on a accessor or a property, since we don't have enough time. Okay. So but you can use it over accessor, this one. So property, accessor, method. For those things, our arguments would be prototype of the class and name and descriptor. And you can also use it on a class, directly on a class itself, class decorator. And for the class, the argument would be constructor. So there are multiple use cases, and you can also use it decorators for the parameter. Suppose we have a parameter of the pilot as speed. Okay, it's a parameter. We can apply decorator like this as well. I'm not defining it. You can apply it like this as well, and you can define this as a function and add some additional functionality and some validations to the speed. Okay, so you can research about that and go into detail, but here we can't cover all of that because of time. But yeah, this is how decorators works. I think I've demonstrated in the methods. So methods are basically majorly where we use decorators and also parameters. So yeah, just keep that in mind and do your research, and you'll get to know how powerful they can be and useful.
Thank you.
Yeah. And yeah, so basically, as I mentioned, right, these are experimental features. So obviously, we'll have a configuration file, TypeScript config, tsconfig.json is nothing but a set of instructions to our TypeScript compiler to follow. So there are some options, like when you do tsc npx tsc. This is like I'm not gonna actually run it, but when you do this, okay, npx tsc -- init. This is when this generates this file. So this is all like stub generated, okay. And if you see, this target is ES 2016. So if I put this target to 13 or something, 14, ES 20, ES 3, ES 3, you should see an error here. If you see here, it says accessors are only available when targeting ECMAScript 5 or higher. Okay, because these are new features, right? So what this target is trying to do is this TypeScript is trying to, so whatever target you give, this version of JavaScript, our TypeScript compiler compiles it into that JavaScript language version, set the JavaScript language version for emitted JavaScript. Okay. So, but in this JavaScript version, it doesn't understand what accessor is. So you will see error. So this TypeScript config, TS config is like our instructions that we give to TypeScript compiler that would decide how you write your code and what errors you see and all that. Okay. So I will revert it back. 16. So, and if you see here, one more thing is experimental decorator store. This was switched on. So as I mentioned when I started beginning about decorators, these are an experimental feature. So in feature, so in the future they might change the functionality, and this is they are just in stage 2 proposal. So for anyone to work with these decorators, you also have to switch on this experimental decorator setting to true. If you comment this out and save it, you will see error. You see pilot over pilot, you're putting some decorator, but it says experimental support for decorators is a feature that is subject to change. So you'll have to switch on this. So like this, this TS config is very important, and you'll have to always keep in mind when working with TypeScript to make sure what are all the properties that are being set in TS config. Because when you see errors in your file, you will wonder. So most of the times your linter will show, okay, in TS config this error is there, but it's better to know some of the important things in TS config and how they work. Okay. So, and yeah, I think most of you might already know, but if you see no implicit returns, so if you have any code paths, any function that doesn't return anything, and if we set this to true at that time, we'll see that error. So like that, keep it in mind, this TS config JSON. So this is also when you're learning TypeScript and trying to understanding this file clearly gives you ability to understand how the TypeScript compiler works, therefore making you like very efficient in your TypeScript coding. Okay. Yeah, so I think that's I want to cover. And one more thing, anything about on this TS config you want to know anything more, or like uh,
People can easily able to put their questions on the meetup page as well. We are going to answer
yeah,
from there
yeah,
too. So no matters if you guys are not able to find the exact concerns at the moment, but
yeah,
yeah, you can put on the meetup page and we'll be able to answer there.
yeah. Yeah. And just one more thing you might have, I just want to point out when I was executing, right? I was executing in TS node. So this TS node is a package, okay, which will directly execute TypeScript code on Node.js. Okay. So this, if you install this package, you can actually, this is a, if I hit this npx TS node, this creates a REPL. Now I can actually write TypeScript code here. Text string is equals to 5. I will see the error. Error type number is not assignable to type string. So you can actually, this is a TypeScript playground that you can create itself. So this is like a TypeScript version package, which you can use to actually directly run your TypeScript code over Node.js and see the logs and all that. So just keep this in mind. If you guys didn't know about this, this could be very useful as well in your TypeScript development. Yeah. Yeah, I think I've covered most of the parts, and since we ran out of time, maybe some parts we couldn't cover in detail, but I hope session was very informative and you guys learned some things, and also we have learned some things through your questions, definitely. And yeah, if you have anything, any feedback or any feedback regarding the session, you guys can give it now, and we can spend 5 to 10 more minutes in the session. Anybody want to say anything, feel free to say it. We're all ears.
So feedback encourages us to not only to identify new topics, so we will be happy to receive the feedbacks, and whatever the concerns you guys have, we'll happy to address those as well. No matters is on the current chat window or in the meetup page. So
Okay, I mean, yeah. So if you can't come up with it right now, any questions or any feedback would be most welcome in the meetup page. So, and obviously, all the examples that you saw here, we'll be adding them in a GitHub repo, and we'll share the link for that as well. So yeah, and on the meetup page, all of the details will have there, and any of the resources that we have used in preparing for this TypeScript event, and which would be helpful for you to understand the GitHub repo code using those resources. Those will also be attached in the meetup page. And
Yeah.
I very, thank you guys for attending.
Yeah. Recording will take some time to release on meetup page. So it's on generally a 7 week time frame. 7 week, oh, sorry, 7 days time frame, 1 week. So please bear with us for that. So thank you everyone for your patience and support. And we are wrapping this up here.
Thank you.
Can you stop recording?
Yeah.